Hi, my name is Wolfgang Preimesberger, and in this short video I want to give you a quick overview over the QA4SM validation tool that we are developing. You can access the tool for free after registration at qa4sm.eu. This, what you see here, is the landing page, and here you can find some background information on the project. In short, our goal is to develop an online tool that people can use to compare different satellite soil moisture datasets to models or in situ measurements to find out, for example, which dataset fits best for their application, like for a study that they are working on or a new dataset that they are developing. We are building this tool by following community best practices. At the moment, we provide multiple datasets that you can use in your validation. You can find a nice overview in the datasets page here. Here you have all the subversions and also some explanations on potential filtering options for each dataset. I will show an example for a validation to make this clearer next. So after logging in, you can go to validate here, and here you see the main validation interface. On this page, we can build our validation setup. We have two columns. On the left, there are the satellite datasets that are in the service. On the right, there are the reference datasets. We currently have satellite datasets from ESA, NASA, EUMETSAT, and others. In this example, we will use the ESA CCI soil moisture active dataset and use the latest version of it. In the bottom, we can filter the dataset. So for this example, we will only include measurements that are recommended by the data providers. And we will also exclude any measurements that are taken under frozen soil conditions. We can add another dataset, for example, the SMOS data, and also here we only use the recommended data. On the right, we used in situ measurements from the International Soil Moisture Network here, and also here we use only the recommended data. We can even limit the networks to certain continents or certain networks here, but we will mostly leave the default settings, and also we could limit the measurement depths, but we will keep 0 to 10 centimeters here. And as the networks that we have chosen are mostly in the United States, we will limit this validation area to the US here. We can now also define a validation period, like for example, all the data after 2010 is considered. And as we have 3 independent datasets, we can also include triple collocation metrics. In the last 2 boxes, we could activate to validate anomalies instead of the absolute values, but we don't do this here. And we could also select different scaling methods to remove biases between the datasets, but we will leave also here the default. Finally, we can give a name to this validation setup. And when everything is okay, we can click on validate. And now the validation starts, and we will get the email notification with a link to the results. Okay, so it took a few minutes, and I received the email with a link that I clicked, and it directed me to this page. This is the overview over the validation results. So on the top, you can see a nice summary of the settings that were chosen for this validation. And on the bottom, you have some visualizations of your results. So on the left, you have some box plots for different metrics that were calculated, for example, for the correlation coefficient, or also for the triple collocation metrics that we have calculated, like for the signal to noise ratio, for example. And on the right, you have maps of these metrics. So it depends on which metrics you want to visualize. For example, for the correlation coefficient, we have a map between the 2 datasets, so the reference dataset and the ESA CCI dataset, and the reference dataset and the SMOS data. So you basically see where which dataset performs better. You can see that the CCI data is performing a bit worse than SMOS in these areas here, for example. And the same also works for the triple collocation metrics, where you have these maps. Of course, you have less maps for the triple collocation matrix because always 3 datasets are combined in one map. And in the bottom, you can also download your results, either the graphs only as a zip file, or you can also download the netcdf file that was generated, for example, to create your own plots afterwards. And in the top, we have a few options to further process our data. For example, we could now click this publish button, which would send the results to Zenodo, where they would be archived and assigned a DOI. And I won't do this now, but I can show you for some other validations that were already published before. So for example, if we look at this one, this was a global validation of CCI combined for 2 different versions that we ran against error 5 in this example. And this one was published on Zenodo and has now a link there. So yeah, you can send this to other people and they can simply download, for example, the netcdf file that was generated, or there's also a nice citation text here that you can copy, for example, for a report or a paper that you're writing. So this was just a short overview over some of the features that we currently have in the service. Feel free to visit it and try it out for yourself, or browse through the published validations. I think this is a nice overview over some of the results that we have already used. And yeah, if you have any questions, feel free to send me an email. Otherwise, thank you for joining this video.